second form of a quadratic function called standard form. Standard form is a form that you've seen before in previous math classes. And today we're going to learn about how to convert from one to the other and the important features we can find from the standard form. When we get to the important features, it's important that you copy these down onto your note sheet so you have them all in one spot along with how you determine the important features of a vertex form. So standard form for a quadratic is y equals, or f of x. Getting back to function notation, we'll look at that a little bit today, but it's ax squared, so there's your independent variable x, plus bx plus c, where a, b, and c are just numbers. They're your coefficients, they're constants, and again we could use function notation as well. So looking a little bit differently than vertex form, we're going to be able to find different important features of a quadratic a little bit easier or a little bit more difficult depending upon what feature we're looking at than we did for vertex form. But one thing you need to know is how do we convert from vertex form to standard form. Alright, so the key to knowing how to convert from vertex form to standard form is knowing how to FOIL. You've been foiling for a while, and this is just putting that to good use. So if I ask you to convert the following equation, excuse me, y equals x minus 1 quantity squared plus 2. So this is vertex form with vertex 1, 2. We can do axis of symmetry is x equals 1, all those important features, but how do we make this into standard form? Well, the key is understanding that x minus 1 squared means x minus 1 times x minus 1. This is just using the definition of what squared means. And now that I've got a binomial here, x minus 1 times this x minus 1, we can FOIL that out. Again, you can use a square method, or at this point we should really try to use the fact that we do x times x for x squared, the firsts. Then we do the outers. X times negative 1 is minus x. And then we do the inners. Negative 1 times x is minus x. And negative 1 times negative 1 is positive 1. So we're just going to do that multiplication first and leave the addition on the end, just like what we would do with order of operations anyway. Now we can combine like terms. Y equals, we have x squared minus x is going to give us minus 2x plus 1. And then, sorry about that, x squared minus 2x plus 1, and then plus 2. Now there's no more combining like terms we can do in the parentheses, so we will just add the like terms of 1 and 2 to plus 3. So this is standard form. A is a coefficient in front of x, so that's really a 1. If there is no coefficient in front, it's just like 1 times. So A equals 1, B equals negative 2, C equals 3. So that's a way that we can use the vertex form to get to standard form. And again, we'll talk about how this form gives us some other important information about a quadratic relatively easy. So let's take a look at one more. So that one was not so bad because we had a coefficient of 1 in front. But what if we have a different coefficient, say in this case 3? So this would be this quadratic, vertex negative 4, negative 5, a value of 3, so it's a vertical stretch times 3. It's concave up. We know all that from vertex form. Again, to convert to standard form, we are going to just leave that a value there and just do the definition of x plus 4 quantity squared is x plus 4 times x plus 4. And then the minus 5 will stay there. So now we're going to leave this 3 out front, and we'll just FOIL the x plus 4 and x plus 4. You could do something with the 3 first, but my advice always to students is take care of this a value after you FOIL. So we get x times x is x squared. X times 4 is 4x. 4 times x is 4x. And of course, 4 times 4 is 16. So I did the same exact thing as I did the last problem. I didn't change anything just because I've got this a value that's not 1. So now I've got 3 times x squared, combining like terms, plus 8x, plus 16, minus 5. Now we just do order of operations. We have 3 times that trinomial, and then minus 5. We're going to do multiplication first. So I distribute this 3 to the x squared, getting 3x squared. I distribute this 3 to the 8x, get 24x. And I distribute the 3 to the 16 to get plus 48, and then I have minus 5. Now all I have to do is combine the positive 48 and the negative 5, and I get the original equation given in vertex form, but now it's in standard form with a equals 3, b equals 24, and c equals 43. So that's just how you convert from one to the next. It's using FOIL, just like you've done in prior math classes, using the distributive property. If the a value is not 1, strongly encourage you to do that after you FOIL. Okay, time to look at important features of a quadratic from standard form. So key features. From standard form. Again, just like I did with vertex form, every time I'm going to write down y equals ax squared plus bx plus c. I'm going to write down standard form so I get practice at that and just know it by heart. And again, you could write down f of x. That's okay. That's just using function notation. So the first thing, and this is on your notes, so I would copy this down onto that note sheet once you get this down in your notebook. So concavity. If you remember from vertex form, the sign of the a value determined whether the graph was concave up or down. It's the same exact thing for standard form. So if a is positive, greater than 0, the graph, the parabola, is concave up. And if a is less than 0, it's concave down. Same exact thing as before. And same thing in terms of the magnitude of the a value. If the absolute value of a is greater than 1, it's a stretch. If the absolute value of a is between 0 and 1, it's a compression or a shrink. It gets shorter. So that's concavity. That's the same thing, exact same thing as it was from vertex form. Now the next easiest thing for standard form is the y-intercept. Remember, from y-intercept is where x equals 0. So if we look at where y equals a times 0 squared plus b times 0 plus c, these terms are just 0. So we get y equals c. So in other words, your y-intercept for standard form is just always 0, c. I want to see the ordered pair 0 for x, c for y. Don't just say c or y equals c. It's 0, c. So this is even easier than it was in vertex form. Same idea, let x equal 0, but the first two terms cancel out, and you're always just left with c. Always, every single time in standard form. Next, the axis of symmetry. or AOS for short, but I want you guys to remember that AOS stands for axis of symmetry, so we'll say that every now and then. There's an equation for this. It's x equals, just like it was for the vertex form, but it's the opposite of the b value in standard form divided by 2 times the a value. Now you have to be careful when you type this in your calculator that you put parentheses around 2a in your calculator. If you don't, your calculator will get it wrong. So make sure if you type that in your calculator, put parentheses around 2a. So that's how you find the axis of symmetry. And now the vertex is not too bad as long as you understand what we're doing here with the vertex. But the vertex is going to be the opposite of b over 2a for x, right? We just said x equals that. And then this is your y value when you substitute opposite of b over 2a in for x. So that sounds confusing. It's going to be a lot easier to see when we do an example, but those are your important features of quadratic in standard form. We'll get to x-intercepts later. But what I want to do is go through an example, because again, the best thing is to get an example here. So let's say we'll use f of x instead of y. Nothing to be scared of, it's the same thing. Let's say f of x equals x squared plus 4x plus 3. Again, when you have standard form, I encourage students to write out a equals 1, b equals 4, c equals 3. I encourage that. Well, it's concave up, because a equals 1, that's positive. That should be pretty straightforward. The y-intercept is just 0, comma c. So 0, comma 3. Now the axis of symmetry is x equals the opposite of b over 2 times a, which is going to be negative 4. Since b is 4, it's negative 4 over 2 times 1. Now, you should be able to do that in your head. Negative 4 divided by 2 is negative 2. I always like to rewrite it without all that stuff in between as x equals negative 2. Now to find the vertex. We know it's negative 2, comma, some y value. The y value is what we get when we do negative 2. So we're going to do f of negative 2. We are going to substitute negative 2 in for x from this equation up here. So it's going to be negative 2 squared plus 4 times negative 2 plus 3. All I did is I substituted negative 2 in for x. So negative 2 squared is 4. Make sure if you type that in your calculator, parentheses around the negative 2, minus 8. 4 times negative 2 is negative 8, plus 3. 4 minus 8 is negative 4, plus 3 is negative 1, so that is your y value. The vertex is at negative 2, comma, negative 1. So again, all I do is I plug the x value, negative 2, for the axis of symmetry in for x in the equation. That's all I do to find the y value. We'll do one more just to make sure that we're getting a little bit of practice. What if it's a little bit more complicated? So we'll use function notation again, and suppose f of x equals negative x squared minus 6x plus 7. Again, the best thing you can do is write down a, b, and c. A is negative 1, b is negative 6, and c equals 7. So, since a is negative, it's concave down, like a frown. Alright, we've got that. Y-intercept is always 0, comma, c. Since I wrote down c is 7, 0, comma, 7. Now the axis of symmetry is x equals, again, x equals the opposite of b over 2 times a. So we have the opposite of b. b is negative 6, so the opposite of negative 6 is positive 6 over 2 times negative 1. So that's going to be 6 over negative 2, which is negative 3. The vertex is going to be negative 3, and I'm going to do this for you, f of negative 3, just to make it look a little bit different. This is just a y value. We, of course, have to compute that, so I'll write that over here. Negative 3, comma. Let's figure out what f of negative 3 is. So we just plug negative 3 in for x. So it's negative of negative 3 squared minus 6 times negative 3 plus 7. Negative 3 squared is positive 9, but we have that negative up front, so negative 9. Negative 6 times negative 3 is positive 18 and plus 7. Negative 9 plus 18 is 9, plus 7 is 16. So f of negative 3 is 16. So there's your vertex, negative 3 comma 16. If I were to quickly sketch a graph, here's negative 3, here's 16, and we know it's concave down because the a value is negative right up there. So that's finding some of the important features from standard form. We'll do x-intercepts later, but you should be able to sketch a graph, be able to get concavity of y-intercept very easily. Axis of symmetry is going to take time with that equation, and then the vertex is just going to be remembering the function notation that we've learned earlier this year.